So they're kind of a little sneaky. Read very carefully on those. Another example when it comes to conditional probabilities, okay, that whole idea of given. You may have to think about kind of selection. So if we go to a standard deck of cards and draw 2 cards, find the probability of, okay, the first one here, the second card is a diamond, given, remember that slash is given, the first card is a diamond. Now, again, there's no chart here, so it's really hard to do that numerator, denominator setup, but think about your selection here. Given the first card was a diamond, you took 1 diamond out, you're keeping it in your hands, and then you want a second card that's a diamond. Well, if 1 is in your hand, how many are left? Well, 13 minus 1 means there's 12 diamonds remaining, and of total cards, again, you took 1 out, so it's out of 51 cards, and you divide, you get 0.235 as your probability. All right. So you kind of have to think about what you're taking out and what's remaining. In the second one here, find the probability that both cards are diamonds. Okay, now you're actually considering both selections here. Okay, so you go in, that first pick, you won a diamond. There are 13 diamonds out of 52 cards. And I'm going to multiply, and means multiply. I'm going to go in for a second diamond. I already took 1 out, that means 12 are left out of 51 cards that are left. And when you multiply and simplify, you get 0.059 for your probability. All right, let's do one more here. Find the probability that the second card is a red card given, oops, that looks terrible. Let's fix that real fast. Given the first card was the Queen of Hearts. Okay, so first card, Queen of Hearts. You have that card, you have taken it out of the deck. The second card is a red card. The Queen of Hearts is red. You took 1 red card out. That means there are 25 left out of 51 remaining cards, which is 0.490. Again, my zero's there because I had to round up a little bit. Okay, so there's a lot of different types. You've got charts. You have big story problems where you multiply. You have scenarios where you're selecting. You got to think about what you have kind of in your hands. Okay, it is very easy to confuse probabilities and conditional probabilities involving the same event. For example, if you go back to your college course data, which is probably easier for you to flip and then just listen here, the probability that you go into engineering. Well, there are 1,600 people in the School of Engineering out of 10,000 overall, which is a probability of 0.16. The probability that you get a grade below B, the total there are 3,656, again out of your grand total of 10,000, which is 0.366. Now the probability of engineering and getting below a B. So they're kind of merging those 2 topics together. Well, the 2 together in the middle of the table, when you match it up, there are 800 total, and the and is going to go back over your grand total of 10,000, which is 0.08. And then the last one here, engineering or below a B, or remember is our magic word for the addition rule. Now this one is different still. You would have to take your engineering total, which we found up above as being 1,600 over 10,000. And, or add here. The below the B we already found also up here to be that 3,656 out of 10,000. You should know that you're setting it upright if your denominators are the same. You can't add unless you have kind of a common denominator. So if you add the 2 and divide, 0.526 is your probability. Again, beware, there are a lot of different kind of options when it comes to probability. Conditional, and you multiply, and you add. There's a lot of different things to consider, especially when you're within those charts. Okay, so be really careful. We're going to put this video on the website, so if I went a little too fast for you today, that's okay. You can watch it at home as many times as you please. And I will be back in video form again tomorrow.